This is something that is in the development. It is already practiced in some areas, and I think it will be further developed, and I think it's a very good thing. So actually there is, the material has to be spread out on a kind of belt. Then you get the identification, and whenever you identify something, there is a blast, air blast, and then pushes out those materials. Very interesting system, and I think I see big future for that. Now, for the different kinds of materials to be recycled. Paper recycling is something I think we don't have to discuss that. This is something that really makes sense. It should be done. It is easy if you do the separate collection. If you look at the straight times on the weekend here, yeah, I mean, you produce so much paper here, and it is a pity if you don't recover that, because this is a valuable material, and you can make out of old paper new paper, which is actually standard technology, nothing specific. And also it makes sense from the point of view of the economics. Now this is just the data, gives you a feeling what we are talking about, but we have in Germany paper cardboard production about 19 million tons per year. Now, just to give an idea, to put this number in perspective, we produce about 30 million tons of waste per year. Yeah? So this is actually how much. And we have high recovery rates, and from these 79%, 65 are actually used for new paper production. And you know that China buys a lot of waste paper from all over the world. And the price is between 90 and 100 euros per ton. So we are talking about 220 Singapore dollars per ton. And if you get those values, you can really manage that. This is not subsidized. It's done by private enterprise. Now these are new data I got from the internet here. If you see that the price has gone up. This is very recently by 35 US dollars to 300 to 305 per ton, and this is for waste paper as a pipe substitute. Yeah. So you see, there is a market for that, and actually we ship from Germany or from Europe actually the waste paper up to China. Another benefit is also that if you use recycled paper, you have less water use, less energy use. This is also a part that could be kept in mind. It's not only the money, it's not only the trees that are saved, it's also water and other things. Now this is with glass collection. This is more probably not that interesting for Singapore because you don't use so much glass bottles in Germany. You still have a lot of glass bottles. And we have returnable bottles and so on. And then we have these bins here. You see they are not looking very nice. That's why I'm seeing the subsurface system is much nicer. You see that here, people bring that here and they put in different colors and different containers. And you see here also recovery rates of glass, and it is, you can actually use that 100% made of old glass, new glass. And again, you see here, you have savings in raw materials, sand, and also energy. So this is not only that you reuse the material, but you also recover, and you also save energy. Polyethylene, for example, if you have this separation system that you can actually separate out the polyethylene, export to China, you have some numbers here, and you see the price for exported recycled polyethylene about 280 euros per ton. This is really money. We are talking about 600 Singapore dollars per ton. So it's a lot of money that is in that, and you see that China, because they had such a big demand, actually the prices were really high. Plastic scrap materials, PET, flake, clear materials, these are numbers actually very, very new. I put out of the internet, and you see average prices for these PET flake. Yeah, this is actually already a little bit pre-treated. We are talking about high LDP film with plastic prices. You see those numbers. So there is value in these products, not only from the environmental point of view, but also from the economical point of view, it is of interest. It has to be done. Now, I don't want to go into that for recycling, biorefinery. You know all these things. That is something where there's a lot of research going on in biorefinery, actually making from biomass like a sugar platform, and from this sugar platform you can make new materials, fuel, chemical materials, or from the residues you can make heat and power, or you can also thermal chemical put with that and make also products. This is actually a huge research projects worldwide go over in that direction to do that. Now, this is also, and why I'm showing that is biomass can also be organic waste from different kinds of sources. So there's also potential for the future. Construction and demolition waste. Now, in the past, we filled up our landfills with construction and demolition waste. They were almost half of the material that came in. Now, you can see a lot of material is recycled, and a lot of material has been recycled. And what is interesting, this material can substitute quite a bit of the construction material that is used. So construction and demolition waste, nobody discusses that. This is standard actually what we do. Now we have the EU directive, End-of-Life Vehicles, which is also a very important thing for all the old, and this is the recycling rates by law that we have to meet. And you see very high recovery rates that you have to meet. Yeah? So you recover about 85%, and from these 85%, you reduce 80%. That means about, in total, about 70% in total. And also, what is interesting is they banned actually from the car production those very toxic metals in order to get easier and better recycling. Then we have the electrical and electronic equipment. The same thing, you know, all the computers and so on. What did we do in the past with that? Now they all have to be recycled. The companies have actually to take them back. The companies don't take them back by themselves. They use other companies that do that for them, and they have these target values that they have to meet, and they are pretty high. Now, if you look, 4 kilos per capita a year is the minimum collection rate all over. I don't know how they actually measure that. This is probably not that easy. They have recovery rates of 80 and 85%. So this is great. Now this becomes more interesting now with all the things regarding the rare earths. You know, all these titanium and germanium and whatever you have that you use for mobile phones and those things, that mostly is produced in China. So worldwide there are not many sources for that. Now people are now more investigating how we can actually recover those kind of rare earth from actually the material. Now if we are talking about energy from waste is another thing, also kind of recovered recycling way. And here you can see in Germany, this is the development of electricity generation from the renewable energy resources, and this is up to 2007. And you see how that actually really went up. And why did it went up? Because it was subsidized. The electricity that is produced was subsidized by the German government. So wind energy was subsidized, the biogas, the production of electricity from biogas was subsidized, and hydropower not. That stays pretty constant. There is not much resources or potential, new potentials for hydropower plant in Germany. But you see how fast the wind goes up, and actually now that Germany went out of the nuclear power plant program, now they have to do something. Now they rely very much on wind. This is one of the areas, and the wind mills getting bigger and bigger. And they go into the sea. This is actually what they are doing. And then you see also, I mean, the biomass. The biomass is increasing, but this is not only waste, but it is also wood from the waste wood, it is straw, there's all kinds of different organic materials that are reused because it's interesting also for the people to do that because the energy that they produce is subsidized so that they actually can make also some money. Otherwise, they would not do that. And this is also here biogas, biogenic shell waste, you see that here. So this biomass that includes a lot of them. Also, it includes the biogas production, methane production, and so on. Now this is actually something which is booming in Germany very much, but not only from waste materials, but also from maize mostly. Yeah, from maize they produce a lot of energy. The farmers have huge areas of maize and make biogas. And the biogas was then converted into electricity, and this electricity is subsidized again by, it's not subsidized by the government. It is subsidized through the big utility companies. They have to take it back to a certain price. But at the end of the day, you know, everybody of us is paying for that because this is then the big utility companies put that on the normal, increase the normal energy prices, of course, by that, because they don't pay that out of their own pocket. Now, but we use also this for a lot of agricultural waste. We use that also for separate collected biowaste. And it's coming more and more. In the past, we had a lot of composting plants, but now they convert these composting plants for separate collected biowaste into anaerobic digestion plants because it's less energy intensive. In addition, you also gain energy, and it has a lot of advantages. So, you see, there's a lot of potentials, and the technology is well developed, still further developed, but I think it's something that works quite well. Here you see an extreme situation. Yeah, it is a plant with maize and other substrates, also a lot of manure. It has 20 megawatt production, and I think they have 40 plants here. This is why did they build 40 plants? Well, the reason is only small plants are subsidized. They don't build a big one. They build 40 small ones. Each small one has been subsidized. So that's the reason. But this is not the future. Yeah, this is not the future. Now, biogas utilization options. This is there's also some development in that. We have the production of the biogas. Now, what can we do? Direct use in boilers or in gas engines to make electricity directly, and you can use the heat. Yeah. And then what you can use is also interesting. New thing is that you remove the CO2. You remove the CO2 from the biogas. Biogas normally has 60% methane, 40% CO2. You remove the CO2 and then have natural gas quality. Now with the natural gas quality you can make micronets. So for example, you could do that here if you have 10 houses. Of your big houses you have just a micronet and then supply those houses, just as an example. You can also use a factory or whatever. And you can also use those for cars that are driven on natural gas. So this is quite a new development which we see probably more of in the future. These are turnkey products. Yeah, those things are built in a container and you just plug it in. Of course, you have to do some adjustment, but this is actually how the thing is working. Very nice, also very nice for export. You just put it on the ship, ship it somewhere, and then plug it in. So this is a very good development. Now you can also hydrogen. You know, hydrogen was always very much discussed. Is hydrogen the energy of the future or not? And this is still the question. The car industry, yeah, was very enthusiastic about that. Now perhaps they are a little bit more reluctant. But still, there is also, and this is also in the research phase at the moment, that we can also biologically produce hydrogen and use this hydrogen also for some kind of buses. This is Hamburg is the European Environmental City of the Year.